Hello everyone. Don't let yesterday use up too much of today. My dear students, today we are going to learn P block element, 13th group element, diborane and boron halide and its structure. Now, what do you mean by diborane? Diborane is the formula B2H6. So, diborane is boron hydride. All hydrides of boron is considered as diborane. Now, we may classify the diborane into three types. We may take, that is, boranes. Borane is classified into three types. One is closoborane. What is that? Closoborane and nidoborane and arachnoborane. So, closoborane, nidoborane and arachnoborane. Closoborane is nothing but here BnHn plus 2 is closoborane. Then BnHn plus 4 is nidoborane. Then BnHn plus 6 is arachnoborane. So, borane is classified into three types, that is closo, nido and arachno. Examples of these borane. So, we are take example B2H4. So, it is closodiborane. Closodiborane 4. So, we are taking the naming also. So, it is closodiborane and here 4. So, this di represents number of boron and this 4 represents number of hydrogen. So, it is closodiborane. Now, nidoborane. Example, it is B2H6. B2H6 is nothing but diborane 6. So, that it is diborane and in the bracket 6 represents number of hydrogen atom. And here it is B5 and if it is 5 and H9. B5 H9. Then it is pentaborane. What is that? Pentaborane and it is 9. So, 9 represents number of hydrogen atom. Now, arachnoborane. Arachnoborane example, it is B5. If it is 5, N plus 6. So, it is H11. B5 H11. So, that it is pentaborane 11. Then it is B4. 4 means plus 6. So, that it is H10. B4 H10. Then it is tetraborane. Then it is 10. So, number of hydrogen atom that will be present in that bracket. So, it is borane. Now, we may take that here diborane. Diborane is a type of nidoborane. So, we are take that is diborane. Okay. Diborane, we may take the preparation method of diborane. First one, it is industrial method. So, industrial method of preparation. Industrial method of preparation. In industrial method, we may prepare from boron trifluoride. What is that boron trifluoride? BF3. Boron trifluoride is treated with sodium hydride at 450 Kelvin. 450 Kelvin. Then we are get that is B2H6, that is diborane, and with NaF, sodium fluoride. Now, 2 boron is there, 1 boron. So, we may balance by 2. So, 2 boron, 2 boron. Now, fluorine, 6 fluorine. So, that here it is 6. 6 Na, so that here it is 6. And 6 hydrogen, so it is balanced. So, industrial method from boron trifluoride is treated with sodium hydride at 450 Kelvin. We may get that is B2H6 diborane. Then it is also prepared from sodium borohydride. Sodium borohydride when it is reacted with iodine. Reacted with iodine. Then we may get that is B2H6 and sodium is there and iodine, so that it is sodium iodide and liberation of hydrogen. Now balance 2 boron, so that here it is 2. 2 Na, so that here 2 and iodine 2, so 2 iodine. Hydrogen 8, so that 6 plus 2, so 8 hydrogen. Then the third preparation method. The next preparation method we may take from magnesium boride. Magnesium boride. What is that magnesium boride? That is magnesium Mg3 and B2. Magnesium valency 2, boron valency 3. So magnesium boride. Magnesium boride is treated with hydrochloric acid. Hydrochloric acid. Then we want to get that is B4H10. What is that B4H10? It is a arachnoborane. Arachnoborane. So here magnesium is there and chlorine, so that it is magnesium chloride, and hydrogen is there, so remove as hydrogen. Now it is magnesium boride is reacted with HCl, gives that is B4H10. Now we may take that it is 4 and 2, so we are taking 2. So 4 boron, 4 boron. Now magnesium is 6, so that here only one magnesium, so that is 6. And chlorine is 12, so that here it is 12 chlorine, and hydrogen 12. So 10 plus 2, so it is balanced. So preparation of borane. Now here it is not a diborane, it is B4H10 tetraborane. From this B4H10 is reacted with the hydrogen and form that 2B2H6. So diborane is prepared. So these are the preparation methods of diborane. Now we may take physical properties. Physical properties. Physical properties. We may take the borane. What is that? Boranes. Boranes are, it is colorless. What is that? Colorless and diamagnetic. Colorless diamagnetic substances. So these are colorless diamagnetic substances, and they are highly reactive, so that it has low thermal stability. Low thermal stability. So this is a borane. Now we may take the properties of diborane. What is that? Diborane, and diborane is a gas. Diborane is a gas at room temperature. Diaborane is a gas at room temperature. And it is sweet smell. It is sweet smell. So, sweet smell, and also it is highly or extremely toxic. Extremely toxic substances. So, it is the physical properties of diaborane. Now, we may take the chemical properties. Chemical properties. So, chemical properties of diaborane. And the first one, it is on hydrolysis. So, first it is hydrolysis. Hydrolysis. What do you mean by hydrolysis? Reacted with water. So, diaborane, that is B2H6 on hydrolysis and form that boric acid H3BO3 and hydrogen. Boric acid and hydrogen. So, that here B2 and 1 boron. So, that it is 2 and H6 hydrogen 6 and here 8. So, 6 and 2 it is 8. Oxygen here it is 6. We are taking oxygen, it is 6. So, here only one oxygen. So, that it is 6. Now, we may balance the hydrogen. If you are balancing hydrogen, it is 12 plus 6. So, that 18. So, it is 6. So, that here another 12, it is 6 hydrogen. So, it is balanced. So, hydrolysis of diaborane gives boric acid and hydrogen. The second chemical property, it is reaction with alkali. Reaction with alkali, that is sodium hydroxide. When diaborane B2H6 is reacted with sodium hydroxide or alkali, then it will be formed sodium metaborate. Sodium metaborate, it is NaBO2 and hydrogen. Now, balance it, that is 2 boron. So, here only 1 boron. So, that it is 2 and 2 sodium atom, and here that is 2 sodium atom, and hydrogen 6 plus 2 8, and here it is we are take that is 4. We are taking 4. So, it is hydrogen. So, it is balanced. And then next one, we may take action of heat. Action of heat. So, action of heat. And here from diaborane, that is B2H6, diaborane on heating with a different temperature, it will be gives its higher borane. It gives its higher borane. Suppose we may take, that is for temperature, it is 120 degrees Celsius, and the second one it is 100 degrees Celsius, and the third one at 180 degrees Celsius, and it is 200 degrees Celsius. 200 degrees Celsius. So, 120, 100, 180 and 200 degrees Celsius. Now, and at 120 degrees Celsius, it will be formed, that is B5 and B5 arachnoborane. Then, so B5H11 N plus 6. So, arachnoborane is formed. Then, at 100 degrees Celsius, and it will be formed, that is B4H10. It is also the arachnoborane, that is BnHN plus 6. Then, at 180 Kelvin, and it will be formed, that is B10 and H14. Then it is nidoborane, BnHN plus 4. And at 200 degrees Celsius, it will be formed, that is B5 and H9. It is also, it is arachnoborane. Now, it will be interchanged by different temperature. We may take, this will be changed into this pentaborane at 60 degrees Celsius. Tetraborane is converted into pentaborane at 60 degrees Celsius. Now, this tetraborane is converted into decaborane. Tetraborane is converted into decaborane at 95 degrees Celsius. 95 degrees Celsius. And this decaborane is converted into pentaborane. Pentaborane at 200 degrees Celsius. 200 degrees Celsius. So, these are interconvertibles. Now, these two are, what is that? These two, we are take, that is B5H11 and B4H10 are, that is arachnoborane. Arachnoboranes. And B10H14 and B5H9, these are all, that is nidoborane. It is a nidoborane. So, interconversion from that the lower borane with the highest temperature we are getting that the higher borane. So, different temperature we are getting the different boranes. Okay. And the next one, that is reaction with oxygen. So, reaction with air or oxygen. We may take, that is pure borane. Pure borane. So, if it is a pure borane do not react with oxygen. So, there is no reaction. If it is a impure borane, what is that? Impure borane. So, impure borane only reacted with oxygen. Reacted with oxygen. So, we may take a diborane, that is B2H6 is reacted with oxygen and form that B2O3 boric anhydride, that is B2O3 and water. B2O3 and that water, and it is highly exothermic. How will you identify exothermic? Then delta H. Delta H is nothing but enthalpy. Enthalpy is negative and 2165 kilojoule per mole. So, per mole 2165 kilojoules of heat is liberated. The negative sign indicated the amount of energy liberated. So, we are get B2O3 and water. So, that here B2 over and oxygen and hydrogen. So, here 6 hydrogen. So, that here it is 3. So, 3 oxygen. So, that here it is 3. So, it is 6 oxygen and 6 oxygen. Okay. And the next property we may take, then it is reaction with methyl alcohol. Reaction with methyl alcohol, CH3OH. Diaborane is reacted with methyl alcohol. It will be gives trialkyl borate. So, we are take diaborane B2H6 is reacted with methyl alcohol CH3OH. Methyl alcohol, and it will be gives, that is B, and so that is a boron OCH3 and thrice and liberation of hydrogen. So, it is trialkyl borate. Trialkyl borate. Now, 2 boron, 1 boron, so that it is 2. Methyl group becomes 6, so that here it is a 6. So, 6 hydrogen and here that is 6 hydrogen. So, there are 12 hydrogen. So, that here that is 6 molecules of hydrogen that will be liberated. So, it is methyl trialkyl borate. Trialkyl means CH3 thrice, borate BO3. So, it is otherwise written as, that is CH3 thrice BO3, that is trialkyl borate. Trialkyl borate. Okay. Then next reaction, it is very important in organic chemistry, it is hydroboration. It is an inorganic topic, but it is very important in, that is organic chemistry, when alkene, what is that alkene? Carbon-carbon double bond, and alkyne, carbon-carbon triple bond is reacted with diborane. and form that trialkyl borane. So, we may take, listen, here it is CH3, CH double bond CH2 is reacted with B2H6. B2H6. For our convenience, we are taking B2H6 is written as, that is of BH3, of BH3. So that here B2H6 one molecule, we are taking off molecule, then it is BH3. Now, here it follows anti-Markovnikov rule. So, one of the hydrogen is going to attack here and BH2 group is going to attack here. So, we are take here CH3 and here CH2, the double bond is converted into single bond. Here it is CH2 and BH and that H. So, in BH3, one of the hydrogen is going to here and the remaining BH2 is attached with here. And the same way we are take again, that is CH3, CH double bond CH2, yeah, alkene. And here what is it? One of the hydrogen is cleaved and going to attack here and BH is attack here. So, we are getting, that is CH3, then CH2 and CH2 and here it is twice and it is BH. Then one more molecules of alkene. One more molecule, what is it? Here it is CH3, CH double bond CH2. Now again what will happen? The hydrogen is going to attack here and boron is attacking here. So that the compound is CH3, then CH2 and CH2 and thrice B. It is a final compound. So it is trialkyl borane. Trialkyl borane. So it is very important compound in organic chemistry. From that we may get so many compound, that is alcohol and aldehyde likewise. Reaction with metal hydride. So diborane we are take, that is B2H6 is reacted with lithium hydride in presence of ether. Presence of ether. So with the lithium hydride is reacted with the diborane, we may get very important reducing agent, that is lithium borohydride. Lithium borohydride is a very important reducing agent, you know that. So it is B2, so that it is 2 and 2 Li, so that it is 2 and hydrogen 8, so it is 8. And the same way when B2H6 is reacted with sodium hydride. Sodium hydride in presence of diglyne. Diglyne. What is it? Diglyne. The glyne, that is di means that is 2. Gly means that is ethylene glycol and di-Me is nothing but dimethyl ether. So diglyne is nothing but CH3O CH2, CH2, O, CH2, CH2, O, CH3 is nothing but diglyne. Now, in presence of diglyne, we are getting the most important reducing agent, that is sodium borohydride, NaBH4, NaBH4 sodium borohydride. And here also 2 boron, 1 boron, so that it is 2. 2 Na and that 2. So 8 hydrogen, so that 8 hydrogen. So in presence of diglyne, sodium hydride is reacted. In presence of ether, lithium hydride is reacted. And the next reaction, it is formation of borazine are called as borazole. Borazine are called as borazole. When diborane is reacted with the excess of ammonia, what is that? Diborane, it is B2H6, is reacted with the excess of ammonia. It is 6 molecules of ammonia. And at very low temperature at 153 Kelvin at low temperature. Then it is diborane diammonate is formed. What is that diborane? That is B2H6 and diammonate, that is NH3. So that it is 6. So that here 2 and here it is, here that is 3 and here 3. So diborane diammonate. Diborane diammonate. So it is diborane diammonate. Diammonate. And it is otherwise written as, listen, we are take that is BH2 and here it is BH2 and we are take NH3 twice, BH3 NH2 and it is BH4 minus. So it is plus. So BH2 plus and BH4 minus. Now this diborane diammonate is heated with the highest temperature, that is 3B2H6 and dot 2NH3. Diborane diammonate is heated with high temperature. High temperature. Then we may get the most important compound, that is B3N3H6. B3N3H6, that is 2 molecule and 12 hydrogen. 12 hydrogen. And this B3N3H6, which is known as inorganic benzene. Which is known as inorganic benzene. Inorganic benzene. Inorganic benzene are called as borazine. What is that? Borazine, or it is borazole. Borazine or borazole. Now, you know that is benzene. What is that? Benzene is an organic compound. That is here C6H6. That is carbon and carbon, and here carbon, carbon, carbon and carbon, and here and each one, that is CH, CH, CH and CH, and here the bond, here the bond, here the bond. It is benzene. Now we may take the structure of inorganic benzene. Structure of inorganic benzene. So inorganic benzene. And it is organic. Carbon and its compounds is known as organic. Now it is inorganic benzene. The structure, it is boron and nitrogen, boron, nitrogen and boron, nitrogen likewise. Alternate boron and nitrogen. And here there is hydrogen and hydrogen and hydrogen, hydrogen, hydrogen and hydrogen, and here there is the double bond character. So it is inorganic benzene are called as borazine or borazole. Now let us discuss the structure of diborane. Here the structure of diborane, that is B2H6. Listen, we may take B2H6. It has 12 valence electron. 12 valence electron. How it is 12 valence electron? You know that here boron valency 3. So 2 boron. So 2 into 3. 2 boron and valency of boron is 3. And hydrogen, it is 6 hydrogen. Valency of hydrogen is 1. So into 1. So totally it is 2 into 3 plus 6. So that it is 12 valence electron. 12 valence electron. Now we may take the next one. Here electron diffraction studies. Electron diffraction studies. So electron diffraction studies gives the structure of diborane, and we may take that here, that is boron, and here hydrogen, and here hydrogen, and boron, hydrogen and that hydrogen. So it is this one and another one hydrogen. We may take that hydrogen and here there is hydrogen. Here there is a hydrogen. Okay. So we may take electron diffraction studies that will be gives this structure. Okay. And here there are two type of hydrogen. Two type of hydrogen here. What are they? Here this hydrogen. This is hydrogen. These four hydrogen is considered as terminal hydrogen. So the first one here it has 4 BH and BH and 4 BH are there, then it is considered as terminal hydrogen. Terminal hydrogen. And another one type of hydrogen, what is it? Here BHB. It is BHB. So we are taking it is BHB bond, that is hydrogen and here hydrogen. These two hydrogen is bonded with, it is not in a terminal, so that it is a bridging hydrogen. So 2BHB hydrogen is there, they are called as bridging hydrogen. Bridging hydrogen. So there are two types of hydrogen. One is terminal hydrogen and bridging hydrogen. Okay. Now we may take that the terminal hydrogen. So it is terminal hydrogen. Terminal hydrogen. And how many terminal hydrogens are there? There are 4 terminal hydrogen, that is BH, BH, BH and BH. So these 4 terminal hydrogen has the same bond length. So the 4 BH bond has a bond length which is equal to, that is 119 picometer. 119 picometer. All those 4 BH bonds are same. All those 4 BH bonds are same. Now this BH bond, listen, here there are 2 atoms and any bond is made up of 2 electrons. So bond is made up of 2 electrons. So these 2 electrons, what do you mean by bond? Bond is nothing but forces of attraction to bind the atom. So that here these 2 electrons bind that 2 atoms. What is that? Boron and hydrogen. So the 4 pH bond is considered as normal covalent bond. So this terminal hydrogen has 4 and it has 2 center and 2 electron bond. 2 electron bond. So it is nothing but 2C2E bond. 2C 2E. 2C means 2 centered and 2E, that is 2 electron. So that 2 electron bind 2 atom. 2 electron bind that 2 atom. So that is one is boron and another one hydrogen. So between these bond only 2 electron, it is general normal covalent bond. So that it is 2 centered and 2E bond. So how many 2C2E bond is present in diborane? There are 4 2C2E bond. And the next one we are take, that is bridging atom. Bridge hydrogen. And here how many bridge hydrogen is there? There are 2 BHB bond is there. 2 BHB bond. And here the bond is made up of only 2 electron. This 2 BHB bond is made up of only 2 electron. Made up of only 2 electron, but it will be connected 3 atoms. So it will be connect 3 atoms. 3 atom. One is boron, that is 2 boron and 1 hydrogen, so that it is considered as 3C and 2E bond. 3C and 2E. What is a 3C? 3-centered, and it is made up of only 2 electrons, so that it is 2E bond. So 3-centered 2 electron bond. Listen here. It has a boron, and here there is a boron BHB. What is a BHB? BHB, and it is made up of only 2 electron bond, and it is nothing but 3-centered and 2 electron. 3-centered, 3 atoms are connected by 2 electron. How many 3C 2E bond is there? 1 and another one 2. So it will be present, that is lying above and below the plane. And all these 2 boron and terminal hydrogen is present in that same plane. Is present in a same plane. So terminal hydrogen atom and boron are present in a same plane, and these 3C and 2 electron bond is present lying above and below the plane, and it is considered as banana bond. What is that? Banana bond. So what is that? Banana bond. It is 3-centered 2 electron bond. It is the shape of banana. We may discuss here. Now we may take that the structure. Listen, if you are taking that boron in a ground state, boron atom in a ground state, it has the electronic configuration ns2 and np1. ns2 np1 is the normal ground state electronic configuration of boron, and now it is on excited state. Some amount of energy is required to unpair the electron, and this electron is moving here, so that the unpaired electron is 3, so that here it has 1 electron, and we may take here 1, 2, 1 and 1. So 3 valence electron, 3 off-filled valence electron. Now in B2H6, boron has sp3 hybridization. What is that? Here 1 s orbital, it is s orbital, and 3 p orbital, it is p orbital, is undergoing hybridization and form that is sp3 hybridized orbital, that is 4 sp3 hybridized orbital. 4 sp3 hybridized orbital. So 4 sp3 hybridized orbitals are formed. Now sp3 hybridized orbital has 4 orbitals, so that we are taking that here, that is a boron, we are taking, it is boron, and here 1 sp3 and another one sp3, and here another one sp3, and here another one sp3 hybridized orbital. So that here these are all considered as sp3 and sp3 and sp3. So number of atomic orbital undergoing hybridization, which will be equal to number of hybridized orbital. How many orbital involved? 1, 2, 3, 4. So 4 orbital involved. So that we are getting 4 hybridized orbital. 4 hybridized orbital. Okay. And among this, how many off-filled electrons are there? Only 3 electron is there. So that here 1 and here 1 and one more here. And it is for 1 boron, but here B2H6. So 2 boron atom is there. So one more boron, we may take that here. We are taking the boron atom and one more boron atom and one more boron atom. That is sp3 hybridized orbital, sp3 hybridized orbital and sp3 hybridized orbital. So all are sp3 hybridized orbital. All are sp3, sp3 and sp3 and that sp3 hybridized orbital. Okay. Now here also what is that? Here 1 electron and one more electron and that 1 electron. Now, for a boron atom, one boron atom is there. Now, these two sp3 hybridized orbital, this one and this one. These two sp3 hybridized orbital making overlap with a hydrogen atom of 1s orbital. So, we are take hydrogen. We are take hydrogen is 1s1. 1s1 is nothing but here one hybridized orbital. So, it will be overlap and making a covalent bond with a hydrogen atom. It is 1s orbital and it has one electron. So, it will be become pair and making a covalent bond. Same way, here what is that? Hydrogen atom is there and making a covalent bond. It is hydrogen atom 1s orbital. So, it is terminal bond. Now, the same way here also, what is it? Here hydrogen atom and making a covalent bond, it is hydrogen atom of 1s orbital, and here hydrogen atom 1s orbital of hydrogen and making a covalent bond. So, 4 BH bond, terminal BH bond is formed and it has equal length by normal covalent bond. Now, we may take a banana bond. And in this banana bond, what will happen here? That is one filled sp3 hybridized orbital of boron is making a bond with unpaired or that is a free orbital sp3 hybridized orbital and with hydrogen atom, and here hydrogen atom. So, hydrogen 1s orbital. So, one sp3 hybridized orbital and one sp3 vacant orbital and one hydrogen atom. It is a hydrogen atom and making that a banana bond, that is BHB banana bond. The same way here sp3 filled hybridized orbital of boron is overlapping with vacant sp3 hybridized orbital of boron and also with that hydrogen atom 1s orbital and making that bond. So, it is making that banana bond. So, BHB bond is formed by one filled sp3 hybridized orbital and one vacant sp3 hybridized orbital and one 1s orbital of hydrogen. So, that we are take that is boron and here hydrogen and hydrogen and boron and here hydrogen and here hydrogen and one bond and 2 electron, here hydrogen 2 electron and making that the banana bond. So, it is the banana bond. So, we are taking the banana bond. So, it is the banana in shape, so that it is a banana bond. Banana bond. So, it is the structure of diborane.